we looked at constant velocity. So to introduce this lab, we looked at Newton's fundamental laws of physics and we analyzed them through a real-world example. For my experiment, I used a bottle of setting spray and I rolled it across the carpet in the positive x direction. So we can define the system as a setting spray and the surroundings as the rest of the universe. An important law for this lab is Newton's first law, which states an object at rest stays at rest and an object in motion stays in motion until acted upon by some unbalanced force. Also, we can use Newton's second law, which states the acceleration of an object is directly proportional to its net force and inversely proportional to its mass. So, using these laws, we can apply them to our experiment, and thus, because velocity is constant, there is no acceleration and the net force is zero. So, the motion of the setting spray can be predicted with the momentum principle because we know mass, initial velocity, and force. So here's the tracker video, which shows the real world example, and you can see the setting spray rolling down and the tracker is recording its motion and the time. And one thing I could have done was do the trackers more accurately, but it still showed up pretty linear. And then from the video, some data we can take is the initial time, initial position, and final position. So we can apply the formulas from Newton's second law, which are V final equals V initial plus F net over mass times delta T, and then also a similar equation for position. And because our net force is zero and there's constant velocity, we can use displacement over time to find this constant velocity. So after using the data that we found, the initial velocity can be reported as 0.607 meters per second in the x direction, while the other vectors are 0, because there's no motion in those directions. So for the code, I started by keeping the mass of the system 1, because that represented it, and then I changed the initial position vector to demonstrate the position data that we found, and the same with the initial velocity vector. And then the time, I made it the initial time that we had, and the delta, each time step I made 0.017. And then also I put the while t is less than blank to the final time, and then the F net vector you can change to all zeros because there's no zero net force. And then I updated the velocity and position formulas to the Newton's second law. And then that will give you this graph, the coded model, which shows the linear, perfect progression that the setting spray would have versus the tracker model, which isn't very perfect, but still you can see that it still is somewhat accurate compared to the perfect example, and the perfect example could be used almost as a line of best fit for the tracker. So one of the questions pertaining to this lab is, what if the axes were flipped? And basically I took a few of the first points of the tracker and put them in the negative direction, and it kind of shows a reflection of the graph itself, showing the opposite direction of motion. And then, as I said, the tracker points probably could have been more accurately placed, but it still showed a pretty linear, accurate progression of the setting spray. And some conclusions, what does this mean? Because we know that the net force is 0 for this lab, we assume the object is proceeding at constant velocity. However, we do not know that the sum of all the pushes and pulls that contribute to the conclusion of the 0 net force. And this is because it would be impossible to measure all of these forces. So, thank you for watching the lab.